the LaPlas Institute, a wide range of research is conducted, starting from the quantum nature of matter to theories of the universe's origin. Essentially, the LaPlas Institute encompasses all of physics and even more.
За моей спиной находится сверхвысоковакуумный комплекс анализа поверхности и наноструктур, с помощью которого мы проводим исследования электронных и физических свойств отдельных наночастиц. Вот наши новые технологии с помощью термофотовольтаического принципа позволяют существенно улучшить, фактически экономить и энергетику, ядерный материал и получать более эффективное преобразование.
At its core, the Institute focuses on three main areas: theoretical, experimental, and supercomputing.
Behind me is the ultra-high vacuum system. This instrument is unique in the world because it consists of a source of nanoparticles along with an electron spectroscopy system. In the present time, we use it for the nanostructure system developing in the nuclear battery technology.
Additionally, the LaPlas Institute boasts a powerful instrumental base, including a laser center, the multifunctional laser complex ELF, and the tokamak MEPhI. Over the past 3 years, developments such as nuclear battery, atomic clocks, and plasma ion engines, as well as plasma test, have emerged, all of which are currently undergoing testing in real-world conditions.
We are very proud that our tokamak is one of only two which are adapted for mass student participation. We welcome students starting from very early in their education, and even starting from the second year of your bachelor studies, you can already start working with us. In the next 5 years, we are planning to build a new tokamak and welcome you to join us in this endeavor.
The international scientific community considers this as the future source of limitless clean energy.
The demand for our specialists is very high.
Behind my back, you can see a student's project which were done in the first year of study. We try to teach them here how to transfer the simple idea to the real work project.
MEPhI is not just a nuclear university. It encompasses a wide range of fields related to experimental and theoretical physics, mathematics, engineering, and supercomputing technologies.
We believe that this educational technology, which is based on STEM principle, project-based learning and gamification, exists only in MEPhI. So here you can see the National Geographic where our student present her own project.
Using additive technology, students print such 3D models over here.
We offer educational programs in English, Bachelor's degree, Applied Mathematics and Physics, Controlled Fusion and Plasma Technologies, Master's degree, High-Tech Plasma and Power Plants, Controlled Thermonuclear Fusion and Plasma Technologies.
Here we are at LaPlas, at the Center for Multiphysics Simulation and Supercomputer Modeling. Here we conduct numerical and mathematical modeling for processes, for developing models of things such as plasma thrusters.
And where exactly can me and my colleagues use this knowledge?
Here in the Center for Multiphysics Simulation and Supercomputer Modeling, we use mathematical models of complex physical processes and create digital twins of different kinds of technique.
And in which field can we find a job?
For example, for aviation, rocket and space industry, automobile industry and energetics. We create digital twins of plasma thrusters and magnetic traps for plasma confinement.
How many people are connected in the supercomputer modeling? And can you please tell me about your team and your core values?
Our field combines physics, mathematics and informatics. We give strong education for our students so you can find an interesting and highly paid job in any kind of technical industry. We are a community of like-minded people. Our team consists of young scientists, students and scholars. Our main values are sociality, clarity and involvement. And everybody is important for us.
We are lighting up our stars.